Today we're stepping into a wild environment where immense industrial power meets totally unpredictable raw materials. We're breaking down the high-stakes world of excavator scrapyard operations. If you've ever watched a massive excavator effortlessly tear through steel and wondered how the person inside that cab actually stays safe, you're in the right place.
So how do you actually battle those critical risks? Well, the site layers its defenses using the hierarchy of controls, which is mandated by the WHS Act 2020. You don't just hand a worker a hard hat and wish them luck. First, they try to eliminate the hazard entirely. If they can't do that, they substitute it, isolate the worker, engineer physical barriers, rely on administrative rules, and then, only as an absolute last line of defense, do they use PPE. Every single action an operator takes in that scrapyard is governed by this exact 6-step framework to protect them from some immense industrial forces. To truly get a feel for this, we're going to follow the chronological anatomy of a shift. Here's our roadmap. We'll start with rules and machine prep, establish our exclusion zones, look at the crazy risks of attachments, tackle high-risk steel cutting, cover loading and mill balls, and finally, execute a safe shutdown. Let's get to work. Phase 1. Rules and machine prep. I want you to put yourself right in the steel-capped boots of an operator who just clocked in for their shift. Before you even think about turning that key, there are strict administrative controls you've got to clear. Operators must actually possess and verify their specific RIMPO 320 competency. But the machine prep is where the real physical defense kicks in. You're rigorously checking engine fluids, bucket pins, and most importantly, hydraulic hoses. Why focus so much on hydraulics? Because in an excavator, hydraulic pressure is literally everything. A single hose failure or leak under pressure means a total, immediate loss of control of your heavy attachment. So, you verify the whole shebang, log it, and buckle up. Moving on to Phase 2, Exclusion Zones. Okay, the machine is cleared. Now we step into the environment outside the cap, where establishing physical boundaries is our absolute first operational defense. An excavator has massive blind spots, and the swing radius, known as the slew path, is a lethal area. That's why the JSA mandates a signed, no entry deconstruction zone. This is the ultimate boundary between a multi-ton machine and vulnerable pedestrians on the ground. The rules here are non-negotiable, guys. The operator has to conduct a 360-degree visual check before every single movement. If someone approaches, all movement stops instantly, the harness sounded, and work does not resume until explicit radio or verbal clearance is given. They use extremely strict traffic management to keep that excavator totally isolated. Which brings us to Phase 3, the attachments. Now, what's really interesting about this is that an excavator is basically a giant multi-tool, and swapping out those tools introduces entirely new ways for things to go sideways. For example, if you're using a hydraulic grab, your primary risk is crushing or dropping unsecured, shifting loads right through the open tines. But if you swap over to the electromagnetic magnet, the risk profile completely flips. Suddenly, your main hazard is a load dropping out of nowhere because of a power failure. Different tools introduce totally unique physical hazards, meaning the operator has to constantly mentally shift gears and apply completely different safety mitigations for whatever they lock onto. But that leads us to a pretty terrifying question. What actually happens when you apply immense hydraulic force to unpredictably stressed steel? Let's find out in Phase 4, High-Risk Steel Cutting. We are officially entering the most dangerous phase of the operation. This isn't just moving metal around anymore. This is destroying it with a massive hydraulic shear. 40 meters. The JSA dictates a strictly enforced exclusion zone of 40 meters during shear cutting. Why such a massive distance? Because when you cut stress steel, you are playing with highly volatile stored energy. The sheer force required to snap thick metal can result in terrifying high-velocity projectile ejections. Shrapnel can fire off literally like a bullet, making 40 meters the absolute minimum safe distance for anyone outside the machine. Definitely not a hazard they cover on your standard driving test. The JSA literally spells it out for us, stating, shear operations present the highest projectile risk of all tasks. To survive this, the operator relies incredibly heavily on engineered controls, specifically thick polycarbonate cab glazing just to deflect flying shrapnel. But it's not just about armor. It requires immense skill. The operator has to carefully calculate their cutting sequences, assessing the tension of the material to avoid a sudden snap or wild shifting of the metal piece. It's like a high-stakes puzzle with literal explosive consequences.
So the steel is cut and processed. Now, how do you safely load it into a truck when one wrong swing of the boom could absolutely crush the driver's cabin?
That takes us to Phase 5, loading and mill balls.
We're transitioning now from destroying scrap to transporting it, which introduces a highly intricate dance between massive machinery and heavy transport trucks. So the crucial point here is that mechanical skill means absolutely nothing without perfect communication. The JSA lays out incredibly strict safe loading rules. A truck cannot even enter the loading zone without explicit radio clearance from the excavator operator. The radio is the ultimate safety switch. Once loading begins, the driver has to stay inside their cab with the windows rolled up. And the golden rule of the scrapyard? You never, under any circumstances, swing a load over the truck cabin. Every single piece must be brought in smoothly over the back of the truck body.
But wait, not all scrap behaves nicely. Enter the mill ball. These are incredibly dense, heavy, spherical steel grinding components used in refining. The hazard here is pretty obvious. They're perfectly round. If dropped from a magnet, they don't just hit the ground and stay there. They roll and bounce totally unpredictably, like deadly steel pinballs. Because of this, the JSA mandates unloading these things into bunkers using exceptionally low transfer heights and making multiple smaller lifts just to prevent catastrophic bouncing projectiles.
There's a massive difference here between a controlled move and a total emergency. A controlled magnet drop means the operator intentionally de-energizes the magnet directly over the bunker at the absolute minimum possible height. But the operator has to constantly be planning for a power failure event. If the generator fails, the magnet instantly drops its massive heavy load, so the operator has to proactively plan their slew path. That way, if a sudden loss of power happens at any given second, the load falls onto empty, safe ground, never on people and never on a truck cab. You basically always have to plan for failure.
Finally, we reach Phase 6, safe shutdown.
We made it through the shift, but we're not totally out of the woods yet. In heavy industry, complacency at the very end of the day can still be deadly. You can't just park an excavator and walk away. The end-of-shift protocol is absolutely vital. The attachment must be fully lowered to the ground. Why? Because hydraulic pressure bleeds slowly over time. If you leave a multi-ton attachment elevated in the air, it is quite literally a ticking time bomb slowly creeping downward. You've got to engage the slew lock, apply the park brake, and formally log any defects. The JSA also flags a critical WHS legal mandate, fatigue management. Operating these massive machines requires intense, sustained concentration, and operators are legally obligated to report fatigue to ensure they don't make a fatal error in the final minutes of their shift.
Which leaves us with this final thought. Knowing the insane hydraulic pressures, the terrifying projectile risks, and the incredibly strict hierarchy of controls that dictate every single movement out there, will you ever look at a scrapyard as just a pile of metal again? Or will you recognize it as the highly engineered, rigorously managed danger zone it truly is? Thank you so much for joining me on this deep dive into the real-world safety parameters that keep heavy industry moving safely.